I'm going to be talking about gradient. Gradient is quite often linked to hills in real life. As you can see in this image over here, we have a hill. Now, we can describe the steepness of that hill by talking about its gradient. Gradient is the measure of how steep a hill is in real life. And in more abstract terms, we can also talk about a straight line, and we would describe the steepness of that straight line on a graph by talking about its gradient. Okay, so you should already be familiar with the equation of a straight line. The equation of a straight line is given by y equals mx plus c, where m is the gradient of the straight line. We call it the coefficient of x. Now, the coefficient is the number in front of that letter. So the number in front of the x is the coefficient of x, and that tells the gradient of the line. And the c in the end is the y-intercept, so where it crosses the y-axis. Now, in this video, I'm going to be focusing on just the gradients, how to find the gradient of a straight line from a graph. And the one key thing that you need to know is that the gradient is defined by the change in y, or in other words, the difference in y, divided by the change or the difference in x. I'm going to be talking more about that in just a second. And the bigger the value of m, the steeper the line. Okay, so now let's look at a graph here. I've got my y and x axes, and I have my straight line here. Now, when you are finding the gradient of a line on a graph, the most important thing is that you need to find 2 points that lie in the corner of the grid. The reason for that, for example here, I'm going to be focusing on this point here. The reason I'm picking that point is because I know exactly where it is on the graph. I know that exactly the coordinate of it is 2, 6. If I'd, for example, picked this point here, I don't know exactly where that is because it's in between. The x coordinate is between 2 and 3, and the y coordinate is between 6 and 7. So I can't know exactly the location of it on the graph. So pick 2 points that lie exactly on the corner of the grid, so you know exactly the coordinate of it. Another point that I'm going to pick, as you can see, is here. I could have also picked this point or this point. Okay, so now remembering that the gradient is the change in y over the change in x. Okay, what you need to do next, I'm going to just draw it in red. So I'm going to start from this point here, and I need to see how I can get to the coordinates just above it. I need to go 1 square to the right and 1 up. So I'm going to write that actually on each arrow. Because I've gone to the right, that's a move of positive 1. I've gone from 1 to 2 on the x-axis, and because I've gone up from y to 6 on the y-axis, that is also a positive 1 in the y direction. Now the gradient is the change in y. That means how much have you travelled in the y-axis? Well, I've travelled just 1 up the y-axis, and the change in x, how far have you travelled in the x-axis? I've travelled just 1 in the x-axis. And 1 divided by 1 is just 1. So this orange line here has a gradient of 1. That is quite a low number, so it's not a very steep line at all. Moving on to another example. Okay, first thing you need to do is find 2 points that lie in the corners of the grid. So I'm going to pick this one here, and this one over here. Okay, what you need to do then is to draw in your arrows. So I need to travel 1 in the x-axis. I've gone from 0 to 1, so that's a travel of 1 on the x-axis. And you need to move 1, 2, 3, 1, 2, 3 squares up. In the y-axis is positive because I've gone from 2 to 5. Gradient is the change in y over the change in x. So my gradients for this line, the change in y, I've travelled up 3, divided by the change in x, I've travelled across 1. 3 divided by 1 is 3. So this line has a gradient of 3. Now if we just quickly compare the two lines, this one had a gradient of 1. You can see this one is more steep. This one is less steep. And if there were hills, obviously this one would be steeper in real life if you had a gradient of 3. One thing to also note is the direction of the line. It's going in this direction and it has a positive gradient, similar to the first example here. It has a positive gradient. Now moving on to an example like this, you can see a change in direction. I'm now traveling in this direction. It's the exact same steps, but you'll notice how the gradient changes. Okay, I'm going to pick 2 points. I know that this lies in the corner and this point also lies in the corner. Now remember, I need to track how far I travel in the x-axis first. So I'm going to draw my arrow. I've gone 1 to the right. So in the x-axis I've travelled from 0 to 1. So that's a movement of 1. And now I need to move 2 squares down because I'm going from 5 to 3. So that is a movement of -2 because I've gone down in my y-axis. To find the gradient of this line, difference in y over the difference in x. Well, the change in y is -2 and the change in x is 1, +1. -2 divided by 1 gives us -2. So this is telling us this line has a gradient of -2. It's negative because of the direction it is going in. Just one more example then. Okay, from now on, because we've now seen a positive and a negative gradient, we can make some assumptions before we work anything out. And I would really recommend this when you answer these questions. Look at the line. Is it going in the positive or the negative direction? It's going in the positive direction. So I'm going to be expecting a positive gradient. So let's pick 2 points. I'm going to pick this point here and this point here. Okay, let's travel in the x-axis first. We need to travel 1, 2, 3, 4 in the x-axis and up 1 in the y-axis, so that's a +1. And the gradient here is the difference in y over the difference in x. Difference in y, I've travelled up 1, it's +1, and the difference in x was 4. Now you'll see that 1 divided by 4 can't really be simplified anymore. It's a quarter, so you can leave it as a fraction or you could write it as a decimal. That's also fine. So the gradient here is a quarter. Now if we compare that to the gradient of 1 is steeper compared to a gradient of a quarter because 1 is bigger than a quarter. So you can also have, as well as negative gradients, you can also have fractional gradients.